This tutorial is to cover topic 4.6 on amines. The first thing we're going to look at is part A, which is the formation of primary aliphatic amines from halogenoalkanes and nitriles. So to start off with, we'll look at the formation from halogenoalkanes. We'll take an example as bromoethane. The overall reaction is as follows, where you form your amine and hydrogen bromide. The conditions are that you warm it in a sealed container with excess ammonia. You might want to think about why it's in a sealed container and why we use excess ammonia. If we have a look at the mechanism for this, then first of all we'll need to put on the delta plus and delta minus. You should remember that bromine is more electronegative and will therefore have the delta minus, which therefore means that the carbon will have the delta plus. The ammonia molecule, remember, has a lone pair of electrons. So if we look first of all that these lone pair will be attracted to the delta positive on the carbon atom of the halogenoalkane. And we'll draw that curly arrow. Remember, it's important that the curly arrow starts from the centre of these lone pair of electrons. Because of this, the electrons in this bond will then expel the bromine. So you end up with CH3, CH2, with your NH3 attached. Remembering now that this nitrogen will have a positive charge and you've also expelled your bromine. The next stage of the mechanism is that another ammonia molecule with the lone pair will then form a bond, so we'll draw a curly arrow towards the hydrogen. These electrons will then obviously be attracted to the positive charge, and you end up with, if we just have a look, you end up with your your amine plus NH4 plus, and then overall we put our Br minus. The second thing we're going to look at is the formation of your amines from nitriles. So if I just swap these over, there's no mechanism for this, so we're just going to take a general nitrile. Okay, so remember, you can recognise a nitrile by the C triple bond N. This is an example of a reduction, so therefore you use a reducing agent. And to show this, we just represent it by adding a certain number of hydrogens. In this case, it will be 4. The suitable reagent would be LiAlH4. Remember, it needs to be a non-aqueous solvent. Try and recall why this always has to be a non-aqueous solvent. You then produce your amine.